All right, this type of radical equation, we have some other stuff. There's not just a number on the other side. So first thing to always remember, any radical equation is you have to get the radical by itself. So that means in this particular problem, I have to add the x. I've got to get the radical by itself. So I'm going to add the x over to this side. So I've got the square root of, whoops, that's not what I have at all. I've got the square root of 11 minus x is equal to x plus 1. Just like the problems where it was a square root equal to a number, I am now going to square both sides of this problem. So I'm going to square the square root of 11 minus x, and I'm going to square the stuff on the right side. Now, something big to remember here. When I square the right side, I cannot just square the terms. You cannot just say this is x squared plus 1. That is a dreaded math error. Okay, don't forget we have a binomial over here that we have to square. The left side, when I square that square root, the square root of 11 minus x squared is 11 minus x. The right side, if you need to, in order to remind yourself, write down your x plus 1 times x plus 1. That's what it means to square your binomial. And when I FOIL, my first outers, inners, lasts, I get x squared plus 2x plus 1. This time I have a quadratic that I have to solve. So whether you're going to use the quadratic formula or whether you're going to factor, you put everything on one side, you set this equal to 0. So I'm going to put everything over here with the x squared. So I'm going to add the x to both sides, and I'm going to subtract the 11 from both sides. The reason I'm doing this is I always like my squared term to be positive, whether I'm using the quadratic formula or whether I'm going to factor. That just helps my brain process this a little better. This is going to factor, but if you are going to use the quadratic formula, your value of a is 1, your value of b is 3, your value of c is negative 10. We will all end up in the same place with the same values. The two values of negative 10 that are going to add up to positive 3 are plus 5 and negative 2. So now by the principle of zero products, I have two possible solutions. In this case, x could be negative 5, and in this case, x could be 2. But just like with rational equations, we have a limited domain, so we've got to make sure that these answers end up in our domain. So I'm going to try them and see what my solution set is. So first I'm going to try 2. I'm going back to the very top. Up here, 11 minus 2, it gives me the square root of 9, minus my value is 2. So that the square root of 9 is 3, minus 2 is 1. This first one indeed is a solution. That's great. Now I'm going to check the negative 5. So 11 minus negative 5, 11 minus negative 5, that is the square root of 16, minus negative 5. Square root of 16 is 4. 4 minus a negative is 4 plus 5. That's 9. That is not equal to 1. So this is a fake answer right there. That happens sometimes when you solve your radical equations because you are squaring. Sometimes you end up with fake answers. So sometimes both answers will work. Sometimes neither will work. Sometimes only one will. In this case, only one did. So my solution set is 2.